Hello everyone. Okay, so in this video we are going over how to calculate expected value and fair games. So what is expected value? So the expected value of something is just, say for example, I have a spinner here. There's a spinner. 1, 2, 3, 4, right? The expected value would be, if I kept spinning the spinner, right, what would the average outcome be? And how do we calculate that? So if I was to do this like 1,000 times, what would be the average outcome? And how we calculate expected value is we to find it, we multiply every possible outcome by the probability for that outcome and then add all these values together. So what do we mean by that? I'll show you here by doing an exam paper question. So a biased dice is used in a game. So remember, biased means it's not fair, right? So it's not going to be 1 in 6 like from the normal dice. The player wins an amount equal to the face value on one throw of the die. The probabilities of getting 6 different numbers out of the die are shown in the table below. Right? Sorry, that table is here. Right? Find the expected value of the random variable x, where x is the number thrown. So it's here. So what we need to do here is you set up a box, right? You put your outcome here. Now, my outcome is I win money based on what number I draw. So this here, if I get a 1, I get €1, €2, €3, €4, €5, €6, etc. I get the probability of events. So it was given to us here. In some questions you might have to calculate yourself, but in this case it's given to us here. So I have a 25% chance of getting a 1, 25% chance of getting a 2, 15% chance of getting a 3, 15% chance of getting a 4, 10% to 5, 10% to 6. And how I find the expected value is, I multiply these two numbers together. So 1 times 0.25 is 0.25. 2 times 0.25 is 0.50. 3 times 0.15 is 0.45. 4 times 0.15 is 0.6. 5 times 0.5 is 0.1, is 0.5. And then 6 times 0.1 is 0.60. If I add all these values up, 25, 50, 0.45, 0.60, 0.50, 0.60, I'm going to get 290. So if I were to play this game an infinite amount of times, right, I would expect to make on average €2.9. Now, just because my expected value is, your expected value does not have to be one of the actual outcomes, right? The expected value is just kind of like the mean value of the outcomes, right? When you do it like an infinite amount of times. So, so the expected value of this biased dice is 2.9. So the game costs 3 to play, so that means 3. So €3. The game costs €3 to play. Does this represent good value for money? So if the game costs €3 to play, and on average you win €2.9, is it worth it? No, it's not worth it, because on average you win €2.90, and playing the game with an overall loss of 10 cents per game, because €3 minus €2.90 is 10 cents. So on average you lose 10 cents per each roll of the die. So actuality, you wouldn't be taking part in this game. So that is expected value. So let's have a look at fair games. So you could be asked an exam questions like, is this a fair game? So a game is only considered fair if the expected payout is 0. So fair is a kind of, it's fair for both parties. It's fair for the person playing it, and it's fair for the person who is running it. Right, the expected payout is 0. So if the expected value is €5 and it costs €5 to enter, it's a fair game. So because it's not favouring one person or the other. So let's have a look at a past paper here. So this is 2022. So assume 20% of adults in Ireland jog for recreation. 3 adults are picked at random. Find the probability that exactly one of these adults jog for recreation. Okay, so this is a 2-part question, so it's going to lead into something else. So picked at random, exactly one of these adults jog for recreation. So 3 adults picked. So exactly one. So the first one could jog, not jog, not jog, plus not jog, jog, not jog, and then not jog, and jog. 20% of Irish adults jog. So this is going to be 20%, which is 1/5. 1/5 times 4/5 times 4/5 plus 4/5 times 1/5 times 4/5. So this is independent events. 4/5 times 4/5 times 1/5. Add all of that up, you'll get 48/125. So the probability of one person jogging is 48/125. So let me just double check the maths on that. 4/5. Yeah. Okay. Let's look here. Sinead is joining a gym. She'll be able to use the gym and go to classes. She could pay for individual classes at €6 per class. Sinead estimates that there is a 30% chance she will go to no classes in the year. There's a 60% chance she'll go to 1 class a week, so 52 classes in a year. And there's a 10% chance she'll go to 2 classes a week, so 104 classes a year. Use these figures to work out the expected value of the cost of the classes for a year. So she is paying €6 per class, right? And she's doing the probabilities in her head. And she want to find out, okay, how much am I going to expect myself? How much am I going to expect to pay, right? So she has a 30% chance of no classes. So she has a 30% chance. So let's do out my table. So get a little thing here. Do my box. So, x p x dot p x. So she goes to no classes in the year. So how much is she spending in the year? She's going to be spending €0, right? Then she has a 60% chance. So that's going to be 0.3. She has a 60% chance of going to 52 classes a year. So I'm looking over here. 52 classes a year. So 52 times 6. So she has a 60% chance she's going to spend €312. And then finally, she has a 10% chance of going to 104 classes in the year. So 104 times 6 is 624. So that is 52 times 6. This is 104 times 6. And there's a 10% chance of going. So what's the expected value? 0 times 0.3 is 0. 312 times 0.6 is 187.2. And then 64 times 0.1, which is 62.4. So add them up. 187 plus 62.4. That's going to give me €249.6. So Sinead is doing the maths in her head. She's like, okay, if I do my probabilities and everything, my expected value is around €249. Right? So she hasn't committed anything. She just kind of rationalize it in her head a bit. So she could, on average, she could spend €250. 250-ish euro. Let's look at this one here. A game called, this is from 2018 paper, so a game called Rainbow uses an unbiased circular spinner. The spinner has 7 sectors colored red, orange, yellow, green, blue, and indigo, and violet. So the table below shows the angle of each sector. It shows the cash prize that a player will win if the spinner stops in that sector. So red, what's the probability it stops in the sector? So the angle is 72. When I'm dealing with a pie chart, the probability is always the angle over 360. So it's going to be 72 over 360. Right? So this one here is going to be 72 over 360. 1/5. 30 over 360, which is going to break down to 112. 45 grand. 90 over 360. That is going to break down to 1/4. 60 over 360 breaks down to 1/6. 18 over 360. That's going to break down to 120. 45 over 360 is going to be equal to 1/8. So there's all my probabilities there. So complete the probability column, which is probably the spinner coming to rest in each thing. Okay, done that. Find the expected value of the prize that the player wins if they play Rainbow. So if they land on red, you get 20 euro. Land on orange, you win 60. 24 for yellow, 8 for green, 42 for blue, 90 for indigo, 48 for violet. Violet? You're turning violet. Right, so expected value. So my table is kind of set up there. So I multiply it out. So 1/5 times 20 is going to be, so 20 times 1/5, which is 4 euro. 1/12 times 60, which is 5 euro. 1/8 times 24, which is 6 euro. 1/4 times 8, which is 2 euro. 1/6 times 42 is equal to 7 euro. 1/20 times 90 is equal to 4.5 euro. And then finally 1/8 of 48 is going to be 6 euro. So my expected value is going to be equal to 4 plus 5, 9. 9 plus 6 is 15. 15 plus 2 is 17. 17 plus 17 is 14. 14 plus 4.8 is 18.5. 4.5 is 18.5. 18.5 plus 6 is 24.5. So 4 plus 5 plus 6 plus 2 plus 7 plus 4.5 plus 6. 34.5 euro. So on average, if you were to play this game, you can on average win 34.5 euro. So if you were to kind of put this in context, right? In order for you to make a profit on this game, the cost of entry has to be less than 34.5. But if you want to lose money, don't want us to lose money. If the person playing the game wants to scam you out of money, they're going to make the ticket price bigger than 34.5, and then if it's a fair game, the ticket price will be 34.50. Finally, now let's look at the last question here. So this is from the 2010 paper 2, question 7. So the table below gives motor insurance information for fully licensed 17 to 20-year-old drivers in Ireland in 2007. All drivers who had their own insurance policies are included. So there's some stuff. So there are number of male drivers, the number of claims, the average cost per claim. Female drivers, number of claims, average cost per claim. So what's the probability that a randomly selected male driver made a claim in the year? So randomly selected male driver, so the probability that they're male and made a claim, so it's going to be 977 all over 9634, which, corrected 3 decimal places, is 0.1014. And since it's 3 decimal places, So 0.101. Right? What's the probability that a randomly selected female driver made a claim during the year? So it's going to be 581 over 6743. It's going to be 0.086. Then finally, so they actually do, so the expected value. So there's a 0.101% chance of a male making a claim. So x px x dot px. So they can make a claim of 6,100. So 6,108, and the probability of that happening is 0.101. Multiply that together. $616.908, or just €616.91. So that's the average cost. So the expected value of the cost of claims on male driver's policy is equal to the probability of male making a claim multiplied by the average cost per claim. Then the same thing for female drivers. So it's the average cost of the claim, which is 6,051. Multiply that by the probability, which is 0.086. Multiply them together, and you're going to get €520.39. So that is the expected value of female claims, and that's the expected value of male claims. So the male drivers are paying on average $1,688 for insurance in 2007, and the female drivers are paying on average €1,024. Calculate the average surplus for each group and comment on your answer. So note, the surplus is the amount paid for the policy minus the expected cost of claims. So we pay for the policy minus the cost of claims. So they actually told us the formula here, which is happy days. So the males is the insurance policy was 1,688 minus my expected value, which was 616.891. You got that from part D. So the surplus is 1,071.09. And females, it was 1,024 minus 520.39. So the average surplus was €503.61. So calculate the average surplus for each group and comment on your answer. So just comment on the answer. They're not looking for some proper report on it. Just comment on it. Who's paying the biggest surplus? Well, obviously men. Men are paying the biggest surplus, and that kind of makes sense because men are paying more for insurance in general than women. So male drivers are generating a much higher surplus, so insurance companies are making far more money from male drivers. And then let's look at the last question here. So it's write anything like that down. Like males are surplus is more for males. A 40-year-old female driver with a full license has a probability of 0.07 of making a claim during the year. The average cost of such claim is $3,900. How much should a company charge such drivers for insurance in order to show a surplus of €175 per policy? So we were told formula for surplus there. The surplus is equal to policy cost of policy minus expected value. So the surplus is 1,075. The policy number, I don't know what it is. It's going to be a policy number, policy amount, so it's going to call it P. Expected value is going to be 0.07 times 3,900. So it's going to be the policy minus 0.07 times 3,900. So 273. That's the expected value there. So 175 plus 273 is equal to my insurance policy. So €448 should be the insurance policy. Should be the insurance policy if I want a surplus of €175 per policy. Right, so there were some exam questions there on expected value, and I hope this video was some sort of help. No, not one of my best, but I'm absolutely wrecked. I'm absolutely exhausted. But I'll catch you guys later. Okay, bye.